So far we've looked at translations, but actually the most important kind or class of transformations that we want to look at that are done with matrices are called linear transformations. These are actually not translations, they are things like rotations and dilations and reflections. Now we'll go into those in more detail soon. Starting with just the idea of a linear transformation. So a linear transformation takes, this was a translation, right? Just add an amount to each one. A linear transformation instead takes some multiple of the x-coordinate and some multiple of the y-coordinate to give you a new x-coordinate. And then takes a different multiple of the x and a different multiple of the y to give you your new y-coordinate. This is the linear transformation. Now, this is a matrix unit. We don't actually want to write lots of equations like this. We want to write matrix equations. But this is exactly the same as writing the matrix equation like this. The new x-coordinate is this row times x and y. And the new y-coordinate is the bottom row times x and y. So this equation is going to be what all our linear transformation equations look like. New coordinates equals matrix times old coordinates. This matrix is the transformation matrix. So first question, when can we do this? Well, we're doing this for linear transformations. So we're going to look at the question and go, is this linear? Well, x prime, the new x coordinate, is a linear multiple of, a linear combination of the original x and y, and the y primed is also a linear combination of the original x and y. So this is linear. How would I write it? Well, think about your two equations and go, the new x coordinate is 2 lots of x and 1 lot of y. And the new y coordinate is 5 lots of x and -1 lot of y. So this is my new linear transformation matrix. Here's another example. X primed is x squared plus 5y, and y primed is x minus 3y. Well, this one is not linear, because x squared is not a linear combination of x and y. X squared is squared, not linear. So I cannot write this transformation. Hear this carefully. This is a transformation, but I can't write this transformation using a linear transformation matrix because it's not linear. What about this one? X primed is y and y primed is 2x. This looks a bit different because the x primed doesn't depend on the original x and the y primed doesn't depend on the original y. But if I put in coefficients of 0, then I actually can write it as a linear combination of x and y. So this is a linear transformation. The matrix looks like this. It's got zeros in it because there effectively were 0 coefficients in the original equations. And then be careful of this. These are not linear combinations of x and y. They have a constant term as well. These are actually translations. It's not a linear transformation.